Here's this recording. Okay. Alrighty. So we are going to focus on valence electrons right now. Okay, so I need you to take these notes, class. Alright, so go to the thing that says valence electrons and oxidation numbers. Alright, valence electrons, oxidation numbers. Yes. Valence electrons, did we write down the definition of that? Those are what, Janae? Valence electrons are electrons that are lost or shared in making chemical bonds, okay? It is the valence electrons, guys, that gives the elements their properties. It's the valence electrons that give elements their properties. So, Anthony, we're going to write that down. Valence electrons give elements properties. Okay, they give elements properties. So the reason why group 1 alkali metals give so much is because they have one valence electron. The reason why halogens take is because they have 7 valence electrons. And who is the one that doesn't do anything? Noble gases. And how many valence electrons do they have? They have 8. Okay, so do you need to know all of this for your test next Wednesday? Yes, even though we have a, teacher work day, Tuesday? Yes, you need to know it for Wednesday. So group 1 has how many valence electrons? 1. How many does group 2 have? 2. Okay, generally speaking, the transition metals have 2. They can have more. They're weird. Group 13, guys, how many? 14 is 4. 15 is 16, 17, and 18, 8. Now, everybody wants to have 8. Okay. That is a rule called the octet rule. Okay. Can you see that, Margaret? Through the vlog there, you can see it. How many arms does an octopus have? And an octagon has? So when you hear the word octet rule, that means everybody wants to have 8 valence electrons. Yes, Amari? Okay. The ones at the bottom are technically transition metals. So they will have either 2, sometimes 3, sometimes 4. They're weird. Okay? They're very weird. They're so weird, we're really not going to talk about them that much. Okay? Yes, that's right. I always have to be in the vlog. Alrighty, now, we're going to talk about these oxidation numbers. Okay? Oxidation numbers are the ions that it makes. The ions. Ions are what? Positives and negatives, right? So because group 1 has 1 valence electron, what ions do they make, Caitlin? They have to make +1 ions. What ions does group 2 make? What charge? +2. Group 13? Group 14 is plus or minus 4. This is -3, -2, -1, and 0. Okay? Oh, we're going to find out. Alrighty, now, have you all played ever the game of Monopoly? Yeah. So what we're going to do is we're going to play the game of Monopoly, okay, Haley, and we're going to play a game called Noble Gas Monopoly that I invented. So you need to get like one of those Monopoly pieces, okay? So it could be anything you want. It could be a little eraser, a pen cap, a ring. Get yourself a little Monopoly piece because we're going to play a Monopoly game on the periodic table. Kyle, get a, I don't know, something. A bottle cap, a pen cap, a penny. Nobody's ever played Monopoly? How many people have played Monopoly? 2 people? 4, 5 people. Okay. Yes. So we have these little, get yourself a little house. The top hat. Anybody ever use the top hat? There, perfect. Yes. No, this. Right there. There's your Monopoly piece. The name of the game is everybody wants to go to Noble Gas Place. Everybody wants to be like a Noble Gas. Okay? If you are like a Noble Gas, then you've basically won the lottery, you've won the game. I want everybody to put their Monopoly piece right where the element sodium is. Right there. On the giant periodic table, guys. Play on the giant periodic table as your game board. Giant periodic table. Alrighty. So, why? Why would group 1 elements go +1? Well, here's the deal. Everybody wants to be like who? Noble gas. So, Haley, is it easier for sodium to go and take 1, 2, 3, 4, 5, 6, 7 more electrons so it can be like argon? Or is it easier for sodium to give so it can be like neon? Which is easier? Give. Move your game piece back and put it right on neon. What you just did was you made sodium just like a noble gas. Now, what do noble gases have to do? Nothing. So as soon as sodium gives, it's done. It's done reacting. Okay? Does that make sense? It's one space away from a noble gas. Go to calcium. Right here. Calcium. Okay. Which is it easier for calcium to do? Go 16 spaces to the right and gain 16 electrons to be like krypton, or to give 2 so it could be like argon. Give 2, move it back to argon. You lost 2 electrons, and now you're just like a noble gas. See that, Haley? So once it gives away 2, it's done. Noble gas. Okay? Now you ready? We're going to jump all the way to carbon. Put your piece on carbon. Carbon. Right there. Carbon. All right, class. Which way is it easier to go? Give 4 or take 4? Either one. Either one could happen. So so that is what that means. Plus minus 4. Does that make sense? Because if it gives 4 electrons, it's plus, takes it's 4. Okay? Everybody go to nitrogen now. Nitrogen. Which is easier? Give away 5 or take 3? Take 3. Negative 3. Go to oxygen. Give away 6 or take 2? Take 2, and then fluorine. Take 1 more, and it's just like a noble gas. So that's why those are negative. Everybody's trying to be like a what, Dylan? And how many electrons do they have around them? 8. And once in chemistry, once you get 8 electrons, you're a noble gas. Or you're like a noble gas. Okay? All right. Is that easy for you to remember? No, Kyle? Why not? I'm sorry. So, remember when we said we get to the right of the stairs, everything makes negative ions? These take. Well, they take, and they form negative ions. Now, check this out, Kyle. What's 5 plus 3? What's 6 plus 2? What's 7 plus 1? What's 8 plus 0? See? These want to take. They're right next to the noble gas. Have you ever played the lottery ticket? You know, people, when they play the lottery, they have those little ping pong balls, and they look at the numbers. Well, all fluorine has to do is get 1 more electron, and it's like a noble gas. Okay? And okay, Kaya. If you were going to play the $350 million lottery, and all you needed was 1 number to win, wouldn't that be awesome? Well, fluorine just needs 1 electron, and it wins. Okay, so it's going to take that electron. These guys over here, they just need to give away 1, and they're just like the noble gases. Okay, so that's why they're most reactive. These are negatives. Everything to the left will form positives. Do not worry about the transition metals. They're weird. I'll not ask you about those. They can form +2s, +7s, +9s, plus 5's weird. Not going to worry about them too much in high school chemistry. Okay? So you got to know valence electrons that give chemical properties. You got to know the numbers of the valence electrons and the charges. Okay? All right. What you're going to do, Margaret, is you're going to stop that one, and we're going to do another blog.